like a good teacher will. Okay, the 2A table below summarizes the recorded data on self-reported gender association. By the way, the problem did not say that. It said gender, but because I'm a, up-to-date adult, I changed it to self-reported gender association. Also because my child changes their gender every single day they wake up. But anyway, and whether or not a student has a pierced nose or 2 in the eyebrows, 1 in the lip. That's, oh, back to my child. Sorry. Okay. Anyway, no, seriously, there's a lot of them. The only one I don't like is the bull one. Yeah, that's the only one that just like it looks painful. I don't care about all the rest of them. Anyway, so events, let A be male, which in my house can shift from day to day, and let B equal pierced ear. Find the probability of B. Okay, so yes. Okay, so what you want here is the total pierced ear. So total pierced ear is 103 over the total 178. And then you can get flashbacks from me on the summer work video saying proportion will be the decimal, and then you can change it to a percent. Okay, so when this is just asking for one thing, one event, that means it's a marginal probability, which means it's going to be the totals or in the margins. So total pierced ear over total. Who got that one on their own? Okay, half and half-ish. Okay, now this is new. This is called an intersection. And when you read this symbol, you say and. How do you remember that? Well, in Mrs. Talbot's dumb stuff that I use to remember stuff, I just pretend that there's a little bar in there, and that's an A for and. That's how I remember it. I just picture that little bar going across, looks like a capital A, so it's and. Okay, so A and B is yes, pierced ear and male. Over total. Jake, what are you saying? Okay, who got that one okay? Just Jake and Jamie and a few other people? Okay. All right, now, next one. Find the probability of A or B. And how do I know this one is or? Because it's not this one. Yeah. So I put the little bar in the A. If it flips upside down, it's the other one. Okay. There's actually 3 different ways to find it, but we're going to use both. We're going to use 2 of the 3. Okay, and we're going to use a colored pencil. So if you guys could grab your colored pencils. Okay. You guys remember coloring these in summer work? Yeah. Okay, but you just put the word or. We didn't have a fancy symbol for it. Okay, so check for understanding from yesterday. Are the events male and pierced ear mutually exclusive? No, they're not. It is possible to be a male with a pierced ear at the same time. Okay. What that means is I can't just add their probabilities together. Okay, let's talk about why not. Yeah, okay. So the probability or the event male is represented in this column. And the event pierced ear is represented in this column. That's not a column, that's a row. Guys, can you please not talk? This is challenging enough. Okay, we're gonna do this in two different ways. So we're gonna find probability of A or B. The first way is to take all three boxes that have one or the other. So this box here, this 19 people, are they either male or have a pierced ear? Yes. You can still be both, but they're one or the other. This box here, is this male or pierced ear? Yes. Yeah, it's or. Okay. And then this box here, is this male or pierced ear? Okay. I'm going to show you. What? Okay. So the mathematical definition of or is one or the other or both. Correct, because I don't want the totals. I just want to know how many out of the totals. Okay, however, I'm going to use the totals in a second. That's the first way to find or. It's the correct answer. There's more than one way to do it though. Now I'm going to do it in a more sophisticated way. Okay, now, as I said, these are not mutually exclusive. So I can't just add the probabilities together, but I am. So the probability of being male is 90 over 178. The probability of having a pierced ear is 103 out of 178. But there's a problem with that because I double counted something. I double counted this box and I showed it to you double shaded so you could see it. Subtract off the thing that you double counted. And this comes out to be 174 over 178 also. Okay, so you can either add up the one plus the other plus the both, because that's the definition of or. Or is one or the other or both. You can add one or the other or both over the total, or you can say all of the first thing and all of the second thing minus minus their over. Because you can tell this wouldn't be right just from this, because it would be 193 over 178. And yeah, that's not a good final answer for a probability. Please don't leave that on a test, please, please. Okay, anyway, okay, now, another thing, you could actually find this a third way that would be even simpler than these two. And the clue is in the 174. You want to think of a third way? The complement rule. The complement rule, that's perfect, says it's everything else. So she's saying it's everything but the 4. So all you really got to do is take the total minus the 4 and get 174. Okay, but I don't want to confuse the heck out of you with 17 different ways to do something. Okay, but I don't care. It's up to you. Here's the problem with you guys that I need to make sure you're aware of. The book and College Board, when they give you a formula for anything, they tend to give you problems that give you everything but one piece of it, and you have to solve for that last piece. So you need to know what the formulas are. Even if the complement rule makes sense to you here, you're going to need this formula because a lot of times in this book, they give you all the pieces but one. Anyway, we also have to interpret it in context, and it's not the interpreting in this type of situation. All you do is take the letters for the events and put the context back in. So probability that's wrong. That's wrong. That or looks terrible. Oh gosh. Okay. The general addition rule is a formula. Guys, I'm warning you now. They're going to give you all the pieces of it except for one, and you have to solve for the last piece. And the general addition rule is this. So the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Okay, let's talk about the difference between this and yesterday's, where we just added them together. This one works for everything, whether or not they're mutually exclusive. Because if they're mutually exclusive, this piece would just be 0. So this rule works all the time. The other one that we did yesterday where this part's gone is just for mutually exclusive. But again, that's just because then we do know they aren't. There's no time when both of them occur. This is the same thing as that. So the probability of the first thing plus the probability of the second thing minus what you double counted. So minus their overlap. What? So, okay, hold on. Let me show you yesterday's. So, yesterday, we talked about the things being mutually exclusive. And I said the mutually exclusive addition rule was A or B equals just A plus B. That's because A and B is 0. So this part is missing. See, this part would be 0 because there would be no overlap. Well, what I'm saying is, gosh, stop talking. I don't have the attention span for it. Please. What I'm saying is this one works for everything. This one is a special case where there's no overlap. You can use this one for everything. If there's no overlap, that part would just be minus 0 in the formula.
So if you do that, you get 0.
No, it doesn't really work backwards like that, unfortunately. You know, I guess it does. I guess it does. I guess if you had this and plugged in this and this came out to be 0, yes, you're right. That would be mutually exclusive. I don't know if we ever do that. That's cool. Now, I'm kidding. I don't know. I'm joking. Okay, anyway. Okay, Venn diagram time. So we're still doing the pierced ear business, and we know that it's not mutually exclusive. This is a mutually exclusive Venn diagram, but one where they are not has overlaps. You're just gonna have to do your best here. You guys made these before? Mine's a little wonky. It's fine. It's totally okay. I put compasses in the baskets, but people would surely stab each other in the hands, so we can't have those. I had to take the baskets away from 2 classes, table groups today. They were spinning the glue sticks, making noise, and then they were stacking up the stuff to make a supply tower. Okay, so we're going to define this circle as A and this circle as B. All right, and it doesn't matter. You can put them wherever you like. Okay, so this is how it works. You want to start with how many have both. So how many of the people in this survey have both male and pierced ear? 19. So you want to start there, and the 19 goes there. Okay, this section are the people that are male but don't have a pierced ear. So look back up at the two-way table. What number represents? Yeah. 71. This is male, no pierced ear. This section is pierced ear, but not male. 84. Out here is the neither section. And then your total, go right there. A two-way table and a Venn diagram are the same exact thing, to be honest with you, but I find that students really prefer the two-way table. If you love Venn diagrams, that's super cool, but then you're pretty unique. Okay, so we're just going to define these one more time. Intersection is A and B. We're going to say the probability of A and B, please stop talking for the 50th time. This is when something occurs both at the same time. And graphically speaking, we show it with overlap. Okay, contrast this with union. Union is A or B. We will say the probability of A or B. And the definition of that is one or the other or both. We're not done. We're not done. But any questions about that so far? What? What's wrong? Okay. All right. Okay, now I need you guys to do arts and crafts. I need you to find this in your packet. It's on the last page. Cut that out and put that in your book anywhere that you want. While you're doing that, I'm gonna bring you guys note cards. If you want note cards for the test, just let me know. Oh, yeah. No. Kidding. Oh. I was gonna say, short distance or well, I'm from Michigan. Did you guys know I was Michigan? Also, have any of you not received 50 of these yet?
I have received it.
You have received 50? Yeah. Do you need this? Yeah, to try to get it. They give it to everyone and like multiple people have multiple AP classes and they already have it. Okay. All right. Last problem. Okay, so do you ever go to like or watch a cooking show and they're like, oh, we're gonna make steak 3 ways? Well, we're gonna do this problem 3 ways. So it's good because some people have strengths in one way or another, and you should be able to do all 3 different ways. And you know, some people like the formula. Some people like the 2-way table. I don't really know people who like the Venn diagram too much, but you know, we'll see. Okay. A survey reports that 68% of the population uses Facebook, 28% use Instagram, and 25% use both. Find the probability of Facebook or Instagram by the general addition rule, creating a 2-way table, and creating a Venn diagram. Okay, I think because you're all CPM babies, we will start with the 2-way table. Okay, so start here. Oh no. That took me like a really embarrassingly long amount of time to draw. Okay, so we're going to use proper notation here, mostly because I'm lazy and I don't want to write the words Facebook and Instagram. Facebook is going to be F, Instagram is going to be I. A survey reports that 68% of the population uses Facebook. So I'm going to have on my columns here, and it doesn't matter if I started on the columns, I could do this on the rows. You could do it either way, it doesn't matter. And then this is going to be not Facebook. So when you see this, you read Facebook in your mind, and then when you see this, you see not Facebook in your mind. And then your totals are going to be over here. Here, we're going to have Instagram. We're going to have not Instagram. Total. Guess where Mrs. Talbot is? Here. Here, here, here. I'm too young for Facebook and I'm too old for Instagram. I'm somewhere in the middle. The day my mom sent me a text and she was like, can you like my photo? I'm like, I'm off Facebook. That's it. I'm done. I'm not gonna like senior citizen photos. It's not gonna happen. Okay. So what? Oh, my mom is just bothering me because she wanted people to like her stuff. And I'm like, just go do something. Anyway, okay. A survey reports that 68% of the population uses Facebook. That's going to be total Facebook. And we're going to say 68%. You can put percent in a 2-way table. It's totally fine. 28% use Instagram. That's going to be total Instagram. 28%. And 25% use both. 25% Facebook and Instagram at the same time, maybe on the same device, both open at once. Kind of magic. Okay. Now, how do I fill it out? Yes, Josiah. Okay, so 100% in this case is going to be my total. Okay, so what would this one be? 3. Great memory. What would this one be? Oh gosh. 43. The hardest part is the subtracting. Okay, what would this one be? 72. What would this one be? 32. 29. And then you can check yourself and be like, does 43 plus 29 equal 72? Check. Okay, now we're going to find the probability of Facebook or Instagram. Fooey. Fooey. Okay, and I'm going to do this by shading in the 3. So these 3 boxes are the boxes that are one or the other or both. Okay, we could have also gone with the complement rule here and done 1 minus 29%, which would also be 71%. Does anyone have any questions about two-way table creation and how to find or from the table? Do you guys see the pattern? Usually it's these 3 boxes. Okay. Now we're going to find it by the general addition rule. General addition rule is a formula. And that is the probability of F plus the probability of I minus the probability of F and I together because I counted those twice. In this case, you could skip all this business and just read the problem. 68% use Facebook. 28% use Instagram. 25% were counted twice. Not my best Venn diagram. It's a little special. It's fine. Okay, so what I'm going to do is challenge us to not use any of this cheating stuff up here. I see you trying to cheat with the cheating stuff up there. Okay. All right, so okay, a survey reports that 68% of the population uses Facebook. I can't use that first because that would be this whole circle. 28% use Instagram. Oh no, that's this whole circle. 25% use both. That goes first. 25%. 25% goes in that middle piece. Okay, now what I do is to find the part that's just Facebook. Over here, I do 68% minus 25%, which is 43%. Notice now my whole circle adds up to 68. This one you can really just tell is 3 because you see 28. And I'm sure you can do 28 minus 25 in your head. Maybe, maybe not. Okay, so now we can find the probability of F or I. So the probability is one or the other or both. So 43% plus 25% plus 3% is 71%. And then you can use this number to figure out that that would have to be 29 then. Okay. Which one do you like better? I'm a formula gal, so I'm gonna go right to the general addition rule if I have a chance.
I like that one.
Yeah. I feel like you guys are CPM maybe, so you're gonna go straight to the two-way table if you're not super familiar with the rule. I feel like, is there any amazing human being here who likes this? Okay, that's cool. It's very rare. I guess it really just depends on the directions for the problem.
Yeah.
Okay, let's look at our objectives for today and our joke. Yeah. Okay. Did we use a two-way table or Venn diagram to model a random process and calculate probabilities involving two events? Yes. Did we define intersection and union of events?
Yeah.
Did we apply the general addition rule to calculate union of events?
Yes.
Okay, man,
Go.
are we efficient or what? Okay, let me read this to you. This is, oh, by the way, your homework is due Friday. I'm not gonna stamp unless it's late or absent work from chapter 4. Don't do this right away unless you're bored. Okay, but this says the statistics being part drive the distribution. So this is a normal curve roller coaster, and this is an inverted normal curve roller coaster, and this is a Laplace roller coaster. We will not do Laplace. That is college stuff. And this is an exponential roller coaster, and this is a spin roller coaster, and then this is a uniform roller coaster. And it says right here, this part is down. Let's go get, and then it says drinks right there, but I thought that was inappropriate for your age, so I made a text box that was really big and put food over top of it as the X bar. Get it? X bar. It said drinks because it's a college thing, but I thought perhaps we should not have that.
I would never partake in such activities.
Yeah. Oh, yeah. Oh, yeah.
I do custom pieces.
Do you like my giant text box?
No, this is-